We're going to take a look at solving what are called literal equations. Literal equations are equations that consist mainly of variables. Once in a while you'll see a number or a symbol such as pi involved, but the terms consist mainly of variables. And to solve these, people struggle with them a little bit. It's really no different than solving regular equations. You have a specified variable that you want to solve for. You need to move everything else away from that variable to the other side. We'll start with this one, e equals mc squared. We're going to solve this for m. So to solve this for m, we need to get the m by itself. Well, we have a c squared attached to the m with multiplication. So to move that c squared to the other side, undo that multiplication that's there right now by dividing each side by c squared. So if you divide mc squared by c squared, that will be m. And on the other side, e divided by c squared, that is just e over c squared. So we do end up with m is equal to e over c squared. So again, solving these literal equations, no different than solving regular equations. There's really no reason to struggle with them. You have a specified variable that you're solving for. You simply need to move everything else to the other side. Next equation, z equals pi q to the third h. We're solving this for h. So to get this h by itself, we have to move this pi and q to the third to the other side. And everything is multiplied together there on the right side. So to move the pi q to the third to the other side, simply divide each side by pi q to the third. You can do those all in one step. So pi q to the third h divided by pi q to the third would just be h. And on the other side, that is simply z over pi q to the third. So the value of h is z over pi q to the third. We're going to solve this equation, y equals ax squared plus bx plus c, and we're going to solve this equation for a. So we want to get the a by itself by moving everything else to the other side. So we have three things to move here. We have to move the bx, the c, and the x squared all to the other side. The bx and the c are being added, so those will be easy to move. Just subtract those from each side. If you subtract bx and c from the right side, that'll just be ax squared. And on the left side, it's now y minus bx minus c. So we have y minus bx minus c equals ax squared. If we're solving for a, we want to get the a by itself, so now you need to move the x squared to the other side. It's a times x squared, so to undo that, divide each side by x squared. If you divide ax squared by x squared, that will just be a. And on the other side, it's y minus bx minus c all over x squared. So a is equal to y minus bx minus c all over x squared. On this next equation, it's c times the quantity a plus b minus d equals f, and we're solving this for a. Now, as soon as people see parentheses, for some reason they want to immediately use the distributive property. Rethink that. You're solving for a. We want to get a by itself, so the distributive property really is not necessary here. We need to move three things. We need to move the d, the c, and also the b. And we really want to do it in that order. We want to move the d first, move the c, and then we'll be left with a plus b, so then we can finally move that b to the other side. So solving for a, we'll start by moving the d to the other side, add d to both sides. We have c times the quantity a plus b is equal to d plus f. And now we're going to move the c to the other side. It's c times this set of parentheses. So to undo that, to move that to the other side, divide each side by c. So if you divide each side by c, we'll have a plus b is equal to d plus f all over c. Finally, solving for a, want to get the a by itself, move the b to the other side. So to move that b to the other side, you'll be subtracting b from each side. You have a is equal to d plus f over c minus b. Now some teachers or textbooks may want you to put all of that together on the right-hand side by getting a common denominator. The common denominator would be c, and then you could combine those into one term. It's really up to the teacher or textbook, whatever you're dealing with, how they want it done. But in this case, a equals d plus f over c minus b. We're going to solve this equation, x plus y over z minus a equals b for y. So we need to get the y by itself. To do that, you have to move the x, the z, and the a all to the other side. So to move those to the other side, you want to think about what order is going to be the easiest to move those in. It's subtracting a right now, so that'd probably be the easiest one to start with by just adding a to both sides. So if we add a to each side, we end up on the left side now with x plus y over z, and on the right side, that is a plus b. Now again, we're getting y by itself, so we need to move the x and the z. The next easiest one would be to move the z to the other side because it's being divided by z right now. So to move that to the other side, multiply each side by z. The opposite of division is multiplication. So if you multiply the left side by z, that would just be x plus y. And on the right, that would be z times the quantity a plus b. Finally, just need to move the x. To move the x to the other side, subtract x from each side. We'd have y equals z times the quantity a plus b minus x. Now, if you did happen to use a distributive property there, you would have this az plus bz minus x. Well, it doesn't matter whether you use the distributive property or not, the answers are still the same. Next equation, wz plus yz equals bc. We're solving this for z. This one's a little bit different. This is usually what causes people some issues. They aren't sure what to do here because they think about trying to combine the wz and the yz, and then they figure out there's absolutely no way you can do that. What you can do, though, is look for what's called a common factor. So combining like terms is not going to work here. If we're solving for z, you can't put the wz and the yz together. But what you can do is factor out a z out of those two terms. So since z is a common factor of those two terms, think about the distributive property and think about going the opposite of the distributive property. We're going to take out a z. So what we're really doing is dividing each one of these terms by z. So if you divide wz by z, that is w, and divide yz by z, that is y. So it's somewhat going the opposite of the distributive property. We're factoring out a z out of those two terms. So we end up with z times the quantity w plus y. Now again, we are solving for z. That's the reason we did that, is because now we can get that z by itself by dividing each side by this w plus y. So if you divide each side by w plus y, on the left side, that would just be z, and on the right side, it would be bc over that w plus y. So once again, we could not put the wz and the yz together as we normally do, combining like terms, but what we could do is factor a z out. So we factored a z out of those two terms. We had z times w plus y, and then to get the z by itself, we simply divided each side by w plus y. We got z equals bc over w plus y.